In this problem, we are going to find another volume by the method of slicing. Okay, the region R is enclosed by y equal to x, y equal to x square. So let's draw this region. Okay, so this is y equal to x, and then this guy is y equal to x square. Okay, and it says that we have the cross sections are squares perpendicular to the x-axis. So once again, what we'll do is draw, first the line, the slice line. Okay, so in this case, since it's perpendicular to the x-axis, we would have some line that goes this way, perpendicular to the x-axis. We have a line right here. Okay, and what we have is we have squares that are coming out of this. So if you want, you can draw a square that looks like this, and then as the thickness changes, okay, we will have squares of different dimensions moving along the length of the solid. Okay, so again, procedure to finding the volume is pretty straightforward. First, we find the area of the cross section of the solid, and since it's perpendicular to the x-axis, I'm just going to write a as a function of x. The area of the cross to find the area of the cross section, we need to know the length of the base of this solid. So this base, okay, clearly in this picture is the function y equal to x, okay, minus the function y equal to x squared. So you see in this case the area, okay, or rather first let's write down the base. The base would be equal to x minus x squared at any, if we're at any x. Okay, so the area is going to be x minus x squared, the entire thing squared. So we have the area simply in terms of the of x. Okay, and now we can just find the volume. The volume is going to be equal to integral of the area with respect to x, okay, from 0 all the way to 1, and which will be integral x minus x squared, the whole square, all the way from 0 to 1 with respect to x. Okay, so here we have to be careful. First, let's square the whole thing up. We get x squared minus 2x cubed plus x to the fourth with respect to x. And now we can integrate it term by term. We get x cubed over 3 minus 2x to the 4 over 4, and then plus x to the 5 over 5, everything from 0 all the way to 1. And this becomes 1/3 minus 1/2 plus 1/5. Okay, and that becomes we have 15 as our common denominator. We get 10 minus 15 plus 6, and no, that does not make any sense. So we have 30 here. 30 is our common denominator, and we get 10 minus 15 and then plus 6, which becomes 1 over 30. Okay, so the volume of the solid is 1 divided by 30. Now, we could also instead say that the cross sections are, let's say, semicircles. Okay, but this time perpendicular to the y-axis. Okay, how do we do this? So let's take the region once again. Okay, but this time where slices are going to be perpendicular to the y-axis. So draw a horizontal line. Okay, and now what we have is we have semicircles. So as we move along, we have semicircles of various dimensions. Okay, easier to see. Now to find the volume of this thing. Okay, once again we need to know the area of some semicircle. This time, because we are taking slices perpendicular to the y-axis, okay, these areas will be a function of y. So we need to find a as a function of y. Okay, and a as a function of y would be equal to, so at any value y, Okay, what we have is we have a function here. Now you see, since we're dealing with functions of y, we could write the the parabola itself as x equal to square root of y. The straight line we could still write as x equal to y. Okay, so here clearly the parabola is above the other function, so we can rewrite this, the diameter, okay, of the semicircle would be equal to square root y minus y, okay, which would imply that the radius of the semicircle would be equal to square root y minus y all over 2. So the area of the cross section of the semicircle will be 1/2 pi times radius square, which will be 1/2 pi times square root y minus y over 2, the whole square, and that would end up being 1/8, or rather pi over 8 times square root y minus y, the whole square. Okay, now we have the area of the cross section, so the volume would simply be, now in this case it'll be integral of a as a function of y with respect to y. Okay, so this is the difference here. Okay, and then y would go once again from 0 to 1 because that's where they intersect. Okay, and so now we can plug this all back in. We get 0 to 1, pi divided by 8 square root y minus y the whole square dy, and this would be equal to pi over 8, 0 to 1. First we need to square before we do anything else, so you get y minus 2 times y square root y, which becomes y to the 3/2 plus y square with respect to y. We can now integrate this. We get pi over 8 y squared divided by 2 minus 2 times y to the 5/2 over 5/2 plus y cubed divided by 3. And the limits are from 0 to 1. So this gives us pi over 8, 1 divided by 2 minus 4 divided by 5 plus 1 divided by 3, and we end up with pi over 8. The common denominator once again is 30. We get 15 here, then minus 6, so minus 24, and then plus 10, and we end up with pi over 8 times 1 over 30, which makes it pi over 240. Okay, so hopefully that clarifies this process in order to find the volumes given cross sections either perpendicular to the x-axis or perpendicular to the y-axis. All right.